In this video, we're going to talk about the different render modes inside of Blazor. When I was preparing this session, the name of the session was Blazor in .NET 8. When my team saw that, they went, .NET 8? Isn't that like old stuff? So I obviously had to update it and get a little bit of .NET 9 in there as well. But render modes came in .NET 8, and in .NET 9, there's not a lot of news when it comes to different render modes. So let's talk about render modes. You might have seen some of the slides that I'm about to show you in other videos that I've done. It's important to understand all of these things when we talk about the different render modes and how they work in the background. So Blazor, some people love it. Some people haven't tried it yet. Now, this is of course a joke, but this is something that I've noticed around the community, that sometimes people say that Blazor is not for them. Blazor cannot be used because of different things. Many of these people haven't even tried Blazor. They might have seen some performance charts or something like that, and maybe they've heard that the initial load from Blazor is a little bit slow, and therefore not even gonna try it. And in .NET 8, we got some tools or features that remove some of these problems. I don't want to say problems, but some of these issues, perhaps, that people look at and perhaps say Blazor is not for them. My name is Jimmy Engström. I'm a lead developer at a company called Cab Group here in Sweden. I'm a Microsoft MVP for, 11 years now. And I've been running Blazor in production since the release back in 2019. I'm the co-host of Coding After Work podcast. It's a Twitch channel, it's a YouTube channel. And if you're watching this on YouTube, please like and subscribe. That helps us do more of these videos. We talk to a lot of interesting people on the podcast. We invite them to the stream or vice versa. Sometimes we work on different projects. You might have seen that we haven't had a lot of updates lately, and that's just because we just moved into a new house and we're starting to work back to that schedule. But it is a struggle, to be honest. I've written a book about Blazor. The 3rd edition just came out, and these are the only 3 books that has raccoons on the cover. I just finished my Blazor video course on Dome Train. You can use the code Jimmy20 to get 20% off. Enough about me. Let's talk about this guy. This is Steve Sanderson. And Steve Sanderson had a WebAssembly talk. This was back in 2017, I believe, at NDC Oslo. The talk was called Web Apps Can't Really Do That, Can They? Spoilers, they can. So Steve thought, you know what, it would be kind of cool to run C# inside of the web browser using WebAssembly. So we found an open source version of the C# runtime, and he created a console app. So C# console app running in the web browser. But Steve had some experience building web frameworks like Knockout, for example. So he thought, I can do this a little bit better. So when he takes the stage, he has a working web framework, including IntelliSense. He even had the name Blazor already, which is kind of mind-blowing to me. The version that Steve came up with was, of course, WebAssembly, but the first version that came out was actually Blazor Server. So let's talk more about that. There are 3 hosting models, or nowadays render modes. We have Blazor Server, or Interactive Server. We have Blazor WebAssembly, or Interactive WebAssembly. And we have Blazor Hybrid. Now, these different hosting models or render modes only have kind of small differences. And it's all about access. Server has access to internal resources like the database or server resources. Blazor WebAssembly has access to local resources, local computing power through the web browser. And Blazor Hybrid can access local resources, but not only through the web browser or web view. You can access local resources like Bluetooth, for example, on a phone or a desktop machine. Now let's dive into Blazor Server, just so that we have the same understanding on how things work. So what is actually happening is that when we run Blazor Server, the Razor components render some kind of result. Now Blazor is taking over, creating something called a render tree. You can think of these like the shadow DOM, basically. It's the same thing in different frameworks. For Blazor, it's called the render tree. So in this case, it's going to render a button and a header. Great. On the browser side of things, we have the DOM and we have a little piece of JavaScript. The JavaScript connects the browser to the server by using SignalR. So the server knows what it's already pushed over, which is nothing. So it's going to take that, it's going to push that over to the JavaScript, and then the JavaScript is going to update the DOM. Nice. So now we have some content there. So let's say that I click the button. So that event is going to go to the JavaScript over SignalR and into our Razor components. Our Razor components is then going to render something, it's going to run some code and change the outcome. In this case, a very subtle change. It is Blazor rules with a Z and it's changing it to an S instead. So it knows that we already pushed the Z over, so now we can just push over that change. And this is not entirely true because it's a way smaller footprint that is going to be sent over. It's not going to send the tags again. So it pushed over the change and the JavaScript updated the DOM. When it comes to Blazor WebAssembly, it differs just a little bit from Blazor Server. But before we go into that, we need to understand how WebAssembly works. So normally, we would download JavaScript. We would parse the JavaScript and then compile the JavaScript. This is when the JIT interpreter can take over and render the content or run the code. With WebAssembly, we can bypass some of these steps because WebAssembly only needs to be downloaded. We don't need to parse, we don't need to compile it. The JIT interpreter can run WebAssembly without any of these steps. So what Microsoft did was that they compiled the Mono runtime to WebAssembly. And here is where it kind of blows my mind, because the WebAssembly runtime or the .NET runtime compiled to WebAssembly is running your app's DLLs. It's running the framework or .NET files. There's nothing special about these files. It's the same files. The same files that can run on the server can run inside of WebAssembly and inside of Blazor Hybrid. It is kind of mind-blowing to me. In .NET 6, we also got something called ahead of time compile. That means that we can take these DLLs and compile them to WebAssembly. So now the .NET.wasm, which is the WebAssembly file, gets larger, but also the DLLs is still needed for backwards compatibility. So that means that we're going to download the bigger file and we're also going to download all of these DLLs. So the footprint of running AOT is way larger. We're going to come back to footprint at the end as well. So let's back up just a little bit. This is how server works, right? We had the server, we had the browser, and we had SignalR in between. So let's take a look at WebAssembly. We still have the Razor component, we still have Blazor, we still have the render tree, we still have the DOM, and we still have some JavaScript. The difference here is where it's running. We don't have the server anymore. It is now running inside of the web browser. .NET.wasm is going to run the Razor components, it's going to run Blazor, it's going to render the render tree. And then we're going to have JavaScript interrupts from WebAssembly to the JavaScript for updating the DOM. Because WebAssembly don't have any special access. It has the same access as JavaScript, or actually less, because it needs JavaScript to update the DOM. With .NET 8, we got something that they used to call Blazor United. And I want to mention that because some people in the community still refers to it as Blazor United, and older blog posts will still call it Blazor United. But it's just Blazor now. It's just different render modes. So we got a couple of new things. We got static server-side rendering. We got streaming server-side rendering. We got per component render mode. And we got auto render mode. And we're going to go through all of these in just a bit. So static server render mode is when the browser is going to send a request to the server, and the server is going to render some content and then responds back. It's done. There's no interactivity. It's basically just a normal server call, and we're getting static content back rendered on the server. But it's still the same Blazor. It's the same Blazor component that can do all of that. So we're just sending over that response. So this is basically the same with MVC that we've been working for many years. There's no state involved. If I click the button, nothing is going to happen. Or actually, there are options for that as well, but it has a little bit of special syntax. We can still post forms and stuff like that. But that is something completely different. We're not going to talk more about that. Then we have streaming server-side rendering. So that means that the browser is going to do a request. It's going to render some content. And then maybe it just happens to go to a database. It's going to render, it's going to get some data. But while it's doing that, we can send over a part of a response. So we can send over Blazor rules while we're working with the database. And as soon as the database is done, we can continue sending that over so that it's streaming is kind of in the name. So it's not really another response. It's the same response. You're getting back a fetch promise. So it's getting that promise fulfilled in this case. So we can get that feeling of interactivity, but there's nothing really happening. We're just sending the response back in chunks. We also got something called per component. And per component means that we can combine different versions. So we can, for example, run WebAssembly in the browser, but also have SignalR connected and have different components running SignalR. So we can have static components and we can have interactive components using either WebAssembly, Auto, or Server. Now, I would be a little bit careful with this one because you're not sharing state. The server part is sharing one state, the client side or the WebAssembly part is sharing one state, and the server side rendered has a third state. And if the server disconnects, if you don't have any components that are running SignalR for the moment, that state is going to get disposed. It is a little bit tricky to get around, but Rocky Lotka and Carl Franklin has solutions for these different things. So you can check out those solutions if this is the one for you. And I will show you how this looks in a bit as well. Then we have auto mode. And auto mode is kind of cool because when you first connect to the site, it's going to connect SignalR. Or actually it's going to pre-render first. It's going to connect SignalR. So we get interactivity right away. And in the background, it's going to download all the WebAssembly versions that we need to run. Then as soon as that is done and we go to the site again, we're going to get the WebAssembly version instead, which is kind of cool. Now, when it comes to Blazor Hybrid, it works in a very similar way. So let's go back to WebAssembly. This is how it works. It's running inside the browser, right? So the difference when it comes to Blazor Hybrid is, again, where things are running. So instead of running in a browser, we're running on iOS, Android, macOS, Windows, or Tizen. We're running inside of .NET MAUI, and we're running on .NET or .NET for iOS or Android. Same Razor components, same Blazor, same render tree, same DOM, and we can also combine it with native components as well. So we can combine native and hybrid here. So the same Razor components using Blazor Server or Blazor WebAssembly can reach the web. With .NET MAUI, we can reach iOS, Android, macOS, Tizen, and also Windows. And thanks to WebView, we can also reach WPF and WinForms using the same Blazor components. I think this is a very awesome time to be a Blazor developer. You can reach all these platforms. So when it comes to templates, there are 2 templates. We used to have more, but now there are 2 templates. At least for the web, we have a Blazor Hybrid one as well, but we're not going to talk about that in this talk. So we have 2 templates. We have the WebAssembly standalone one, and we also have the web app template. So let's take a look at those for a moment. So first, let's talk about the WebAssembly standalone template. So when we create one, it looks like this. And if we take a look here, we don't have any render modes because the render mode is WebAssembly. We're not going to have any pre-rendering. Everything is just going to run inside of the web browser. So when it comes to render modes, we don't really have that option here. With the web app template, we have a little bit more to talk about. So if you zoom in here, we can see that we have interactive render modes. And interactive render modes, we have server, which is Blazor Server with SignalR. So WebAssembly is going to be pre-rendered and then run WebAssembly. And then we have auto, which is first going to pre-render, connect SignalR, download everything in the background, and then next time when we reach the site, we're going to pre-render the content, and then we're going to get WebAssembly instead. And then we have interactivity location. At what place are we going to specify the interactivity? Are we going to do it globally? So all the pages in your site is going to have interactivity in a certain way? Or do we want to do it per page or per component so that we can specify, well, this page should run WebAssembly, this page should be static, and this page should be SignalR. We have all these different options. So when it comes down to WebAssembly standalone or Blazor web app, it comes down to the initial experience. What do we want to see the first time we run the app? So let's take a look at a demo. So let's start the project here. So we're going to start with a web app template. So I'm going to load the project. I'm going to go into my counter here, and we can see that the counter So I'm going to load the project here, and we're going to see that if I go to my counter component in just a second here, you'll see that we have counter render mode WebAssembly. And if you take a look down here, we can see that we have interactivity auto down here. So if the loading time is less than, I believe, 100 milliseconds, it's just going to skip SignalR and download WebAssembly and run that right away. So if I reload the page, you can see that it's static, and then WebAssembly has loaded. So it's static and WebAssembly. So it's pre-rendering, so it's using static server-side rendering to render the page first on the server, pushing that over, and then we're going to see the result. So you can see that if I click here, you see that it's quite fast. I get a result back quite fast, and then WebAssembly kind of takes over. So let's take a look at the weather here. You can see that it loads fairly fast here as well. I can clear the cache. So now we don't have any WebAssembly at all. So we don't have any. We don't have anything stored at this point. I'm going to click reload. You see that we have static, and then it loads again. And this is one of the problems that we might encounter, because the server is pre-rendering the content, then WebAssembly takes over and loads the content again. There are ways around that, of course. So what we can do is we can use weather with state. So now if I reload, you'll see that we're loading statically, and then WebAssembly just takes over. So let's take a look at that. Let's pop in here to Visual Studio, and we're going to go to Client, Pages, and Weather with State. To get this to work, we need to write a couple of lines of code. We need to inject the persistent component state. This is what makes the state accessible. And then down here, we'll see that when we're loading the content, we also check the persistent state. Do we have any state already in here? So we are trying to get the state back. We have a name called forecasts, and we're getting the forecast out of that method. And then it's going to check if the forecasts are null. We didn't retrieve anything back. If we don't have anything, we want to get that from the source. We're going to generate that in this case. So to simulate that, I have a delay here. It's going to get all the data. It's going to generate all the data. And then when all of that is done, it's going to register on persisting. So it's going to listen to when the component feels like, you know what? I have some content. I want to save that content. That event is going to get triggered by Blazor. So I don't need to think about that. And it's going to persist that as JSON. So basically what's happening is that the server is going to pre-render the content. It's going to store it as JSON inside of the HTML. Then WebAssembly is going to take over. And WebAssembly knows that, okay, so I might have a state. So I should check for that state. And if I do have that state, I'm going to just pick that up and load that instead. So we're not going to generate the data twice. It's not a lot of lines of code to get there. I'm going to show you an easier way as well, but let's pop back to the web browser for now. Now we also have delayed. So I'm going to click that one, and we can see that we have a delayed response back. So if you take a look at the code here, you can see that I'm generating the data, and then at the end here, I am adding that data to the collection or the list, and I have a little piece of delay involved there as well. So you see that it works quite well. But if I'm running this pre-rendered, so if I reload this page, you'll see that it takes a lot of time because the pre-rendering is waiting for the data to be done. And then it's going to send that over to the web browser, and then WebAssembly is going to load. So if you have something that takes a lot of time, pre-rendering might involve this problem. So that's where weather streamed comes in. So we can use the new streaming server-side rendering. So if I click this one, it loads fairly quickly because I haven't shown you the real world example here. So if I reload this page, you'll see that it starts serving data right away. Now it's still static. So it's rendering statically, and now WebAssembly took over and is rendering the content again because we don't have any persistent state here. Now we also have this weather persistent. So let's take a look at that one. So if I reload this page now, you see that it's static. It's serving the data with streaming server-side rendering. And once it's done, it's just going to switch over to WebAssembly because WebAssembly already had the data. And if we take a look at that one, so what I've done here is that I've created a state manager. Now this is just fancy name. So I took all of this code and I added that to a component. So I have the get state. So here I'm sending in a method that gets the state. So let's take a look at that one. So we have a method here that loads the data. It returns a task, a list of weather forecasts. Okay? Now this one has a delay. It's doing this kind of adding each thing to the list. But the state manager handles that. So basically what it's going to do is that it's going to get that method, it's going to run that method and do all the things that we need to do to get content out. But it's also going to persist the data. So if you take a look here in the state manager, we have the method, the get state method. We have a key. We don't have to specify a key. If we don't, it's just going to make up a name for us. And then it's going to do this. It's going to listen to registering on persistent. It's going to check whether or not we already have the data. And if we do, it's going to kind of just set the state. And if we don't, we're going to invoke the get state method. So we're going to get all of that complex code, if you will, for free. What it all comes down to is really the initial load. That's where this template differs. I can also go in here and kind of go with, let's go with server. Reload the page. You see that it's almost instant. You don't really need the pre-rendering if you're running on Blazor Server because it's so fast anyways. But if I change this render mode to WebAssembly instead, you'll see that we didn't see anything until the page or WebAssembly had loaded. So if I click load here, you'll see that it's nothing, and then we get the content. And if I show you the same thing with pre-rendering, so WebAssembly pre-rendered, we see something, and then we get the content. Now, if I change the render mode here, and I go to change render mode, and I'm going to take a look at SSR, for example. So now, the button is not going to do anything because we're now running it statically. There's no interactivity involved at all. So if I change the render mode back to WebAssembly pre-rendered, for example, and I reload it, you see that we go from static to WebAssembly. I'm going to reload that again. You see that static, WebAssembly. So it's quite fast. So let me clear the cache. I mean, now we don't have any WebAssembly stored at all. And I reload it. You see that static is going to be static for a little bit longer. And then we switch over to WebAssembly. So this slow load that we are talking about a lot when it comes to WebAssembly, you're not noticing that as much when it comes to pre-rendered because it's pre-rendered in the content, you get stuff on the screen fast. But if I do a reload here again, you see that the button is active. If I clear the cache, reload, and if I start clicking here, actually was a little bit too slow here. Let's clear it. So nothing is happening until WebAssembly has fully loaded. And that might be a problem. But with .NET 9, we got something new. We got the ability to, I'm going to pause this one. I'm going to pop into, so if I go into the counter component, here. So in .NET 9, we got something new. We got the ability to check whether or not we are interactive or not. Previously, we could check operating system is browser so that we knew that it's running currently in the browser. But for this one, But for this one, we can add disabled and then use the render info and check whether or not it is interactive. So this way we know if the component is currently interactive. So if I run this again, if I go to, let's do WebAssembly pre-rendered. I'm going to clear the cache and look at the click me button here. I'm going to zoom in just a little bit. So look at the click me button here. If I reload the page, you see that it's disabled all the way until we switch over to WebAssembly. If I were to run the same code with server, we're actually not going to be able to, you see it blink, but it is very, very fast, but we're not going to be able to click the button unless it is in interactive mode. So if I were to change it to SSR, I'm going to reload, you see that the button is not clickable because we're not in an interactive mode. I'm going to pop into per component here as well. And if we go into the per component page here, you can see that we're using something new here for .NET 9 as well. Exclude from interactive routing. So what we're telling it here is that I don't care if we're currently running WebAssembly or Server or any interactive mode. This component should not be interactive. We should use static server-side rendering. Because we're also specifying down here, so for the counter here, we're specifying interactive auto. For this one, we're saying interactive auto, but without pre-rendering. Down here, we have the same. We have interactive server and without pre-rendering. Down here, we have WebAssembly and without pre-rendering. And then down here, we have two just for measure, where we have no rendering or no interactivity at all. So if you go back to the page here and I reload the page, let's focus on this top one here. So if I reload, we can see that the pre-rendered one shows up instantly and the non-pre-rendered one takes a little bit more time. Let's take a look at that one once more. When it comes to the server, I'm going to zoom out just a little bit. So when we come to the server part here, so this is running server and this is running server pre-rendered. And if I click reload, you see that it's basically no difference because SignalR is so fast at starting up. But it is a small difference there. Now, if you take a look at the WebAssembly one, so this is the pre-rendered one and this is the non-pre-rendered one. It's quite a big difference. And if I clear the cache first and I reload, you see that it takes a little bit more time. And I mean, this is a very small application. So what you should think about when you do all of this is what is the initial experience that you want your users to have? Do you want your users to have to wait for a little bit? Or do you want your users to have content straight away and then load interactivity with a small delay? Let's end up this demo with just quickly taking a look at the WebAssembly standalone template as well. There we go. And you see that we have this spinner or progress indicator that is going to show up when we're using Blazor WebAssembly, or standalone, I should say. So if I clear the cache and I reload this page, you see that we have that spinner. And if I reload the page again, we already have that in the cache, so it's going to be way faster. So let's clear that once more. Reload, and you see that, well, it takes a little bit of time for WebAssembly to initiate. But if we were using the other way where we have pre-rendered content, we could have all these things already running while WebAssembly is downloading and initiating. So let's take a look at the difference side by side. So over there, we have WebAssembly, and this one is pre-rendered WebAssembly. So you see that we have the spinner and the pre-rendered one, boom, it's there straight away. Let's look at that one more time. You see, done. Still takes a little bit of time. And then we have the reload. We talked about that. That might be a problem. So let's take a look at the delayed one side by side. So WebAssembly loads fast, and the server part is still generating all the content before it can send that over to the client. So this is obviously a bad idea if you have something that takes a long time on the server. And then WebAssembly takes over and loads everything again. Bad idea, of course. So what would happen if we did WebAssembly delayed and we used WebAssembly pre-rendered with delayed instead? So you see that we get content straight away and WebAssembly is still loading. But we still have that problem here because when we're done, it's going to load WebAssembly again, I believe. There we go. So it's loading WebAssembly again. So we have this persistent component state, which I already showed you how it works. So the difference now, if we're running WebAssembly delayed or pre-rendered, streamed, and with persistent state. So we got content straight away. We didn't have to wait for anything to happen. It's way faster, but it's still server generated. And then after a while, we're going to switch over to WebAssembly seamlessly. We're not going to even notice that change. So in .NET 9, we got the exclude from interactive routing. We already talked about that. We also got render info so that we know whether or not we can disable or we can disable if we're not interactive. So now let's take a moment to talk about the footprint, the loading time. As you have seen with all these demos, it is not really a problem anymore. So I asked at a Swedish Facebook group, so what kind of things do you want me to answer? This was before render modes was a thing. And it talked about the footprint, the amount of data that we need to download is just huge. We need to download the whole .NET runtime. That's insane. He was super hostile. I also want to take a moment to kind of understand the sites of today. We're not living where kilobytes matters anymore. Facebook has 16 megabytes of JavaScript. Pinterest has 6 megabytes. YouTube has 4. Twitter or X has 3.4. Stack Overflow has 1.5. Apple 1.25. And the Blazor startup site has about 1.2 megabytes. To be fair, I mean, the Blazor demo site is super small, but you can also add compression, Brotli compression, and all these things is quite easy to add to your Blazor project as well. So it's not really a problem anymore. So what can we do? Well, we can use a progress bar. We can have that perceived sense of speed. And that is included in the template. We can use server pre-rendered, like the one we just saw. We can use Junichi Sakamoto's, a fellow MVP's, pre-render. So it's going to pre-render that content when you're publishing. So you're going to get SEO and faster load and all of that. I actually have a video on YouTube to take a look at. And here's me. Hello. So this is the difference on a site that I've made. So we got no pre-rendering over there and pre-rendering over here. So this site is kind of silly because the site in this case is a very static site. So this is static content. But let's take a look at the difference here. So you see that the WebAssembly one is kind of slow and the pre-rendered one it's pre-rendered. It's already having the content. But this version, you can run it on a non-ASP.NET server. You can run it on GitHub Pages. You can run it on Azure Static Websites. Heck, you can run it from a file share, which is kind of cool. We also have auto mode. So you can use auto mode, or you can use pre-rendering, of course. Or we can use AOT, which has a larger file, but it's also a little bit faster when it comes to loading. So I want to share something that I've been working on. It's a ZXbox. It is a kind of a proof of concept application, I guess. So this is a ZX Spectrum emulator written in C# running on top of Blazor. I'm going to start this one. This is using Skia Sharp, so it's super fast rendering on a canvas. Let's load a game. I'm going to turn off the sound. Can press enter here, and you can see that it runs super smooth. Let me zoom in just a little bit. It's super smooth. It's very pixely, and that is thanks to Skia Sharp, which gives that the pixely effect or the pixely feeling with crisp pixels. So no anti-alias here. So the thing is that I've been working on this game, or I haven't written the game, but I've been doing versions of this game for Xbox, for HoloLens, for Windows Phone, for Windows back in the day. And I have yet not been able to beat this level, the first level. I mean, it's a lot of fun. It's a really, really old game from the beginning of the 80s. I also want to talk about the Blossom extension. I don't want to take too much time on this, but it is a Visual Studio extension that helps with some of the tasks that you do with Blazor. So this is one of the menus. You can generate B-unit tests. This is kind of a beta still. You can create isolated CSS. You can create isolated JavaScript, create code behind files, find component usages, and you can also show Blazor routes. So these are all the routes that I had in my project. And you can just click them and get to that file. So there's a lot of stuff, helpful tooling that is in this extension. So please download that and try it out. Now, if you have any questions, please write them in the comments here on YouTube, and I would be happy to answer them if I can. So when it comes to WebAssembly standalone, we only really have one choice: WebAssembly. The web app template, we can choose all these different render modes or hosting models. So if you're going to start something now, I would definitely use the web app template. You need to have an ASP.NET server in the backend, but that is totally worth it. Now, when it comes to authentication, what is actually happening when you're using WebAssembly only is that you're going to get to the site. It's going to load WebAssembly. WebAssembly is going to say, hey, you don't have access to this. It's going to say, redirect you to Azure or whatever authentication you have. You're going to be authenticated, and then it's going to redirect to WebAssembly, and you're going to hit that load again. It's going to load that data again once more. So you're going to get that initial load twice, basically. It's going to be cached, but still going to take some time. With the web app template, we can first check access. We were checking that right there on the server. And we're accessing the API through a cookie. We're not sending any access tokens to the client, and that is considered to be a little bit safer. So I have a demo of this. Is an internal application that we're building at work. So the left one will load WebAssembly, then authenticate, then load WebAssembly again. The right one will load authentication. It's going to pre-render and then load WebAssembly. Okay? So let's take a look at the difference. The right one here is already done. And the left one is still authenticating, is still loading WebAssembly. Beside that, where we're authenticating, it's the same code. It's this exact same code. I think the difference here, let's look at that once more, because the difference here is just mind-blowing, I think. Done. And the other one is still loading. So if you're thinking, should I use standalone, WebAssembly standalone, or should I use the web app template? This is your answer. This is your sign. The web app template is just going to give your users a way better user experience. So, should we go all in Blazor? Well, as with everything else, it depends. Is it production ready? Absolutely. We're running it in production as we speak. Should you invest time into exploring Blazor? Yes, of course. So will it replace Angular, React, or Vue? Yes, for some developers. So thank you so much for watching this video. And if you want to get in touch with me, please do. I love to talk to the community. Check out Coding After Work and, well, like, subscribe, and I hope to see you at one of our streams.